All right, so it says a playground pool has 2 water slides. The top of both slides are 6 meters above the water. So the tops are at the same height. You start from rest at the top of the tower. If you choose the high slide, you slide off in a horizontal direction 4 meters above the water at point A. So point A is 4 meters. And it says if you choose the low slide, you slide off in a horizontal direction 2 meters above the. So here, 2. Which side takes you further towards the opposite edge of the pool? Neglect the tiny air resistance of air friction. All right. So if you start off here at 4 meters high, you have a greater potential energy at A. The minute you, like the second before you leave that slide. So at A, UG is higher at B, UG. Okay? If at that point, if you were to stop it right there, stop it, all of your mechanical energy is going to be potential at both those spots. So that being said, at A, your mechanical energy, and then the mechanical energy at B. Okay? So if you have a greater amount of energy, it means at the bottom, before you hit that water, you're going to have more kinetic. So more KE at A. Which means A will get you close to the other side. Because remember, kinetic energy is mass times velocity squared. Velocity is your distance divided by your time. All right, we're starting a new unit. The test is next week, so make sure you're ready for it. Work is a force acting upon an object to cause a displacement. Okay, quick reminders on what we do know. We know that force is measured in newtons and we know the formula for force is F equals mass times acceleration. A lot of times force is that weight. If you're doing this and your force is your weight, your acceleration will be due to gravity. Displacement is a distance. So it's going to be measured in meters. That's what we know, 100%. All right, our formula for work is work equals force times distance. Oops, it's not F. W equals force times distance. And so the units are joules, which newtons times meters converts into joules. Just it's a 1-to-1 conversion. So for 1 joule is 1 Newton meter, 1 Newton meter is 1 joule. So So for all intensive purposes, work has the same formula, 100% as energy did. All right. It says the component of the force used must be parallel to the displacement of the object. What that means is that your force has to be going in one direction. Your distance has to be going parallel. So this is good. If your force is going up or down and your displacement is going up and down, that is good. Now, here's where it becomes an issue. If you have a force that's going up and down and a displacement that's side to side, that's not going to work. You're going to have zero work. No work. Same thing. If your distance was here and your force was side to side, there's not going to be any work done. They have to be parallel. A football player pushes a sled with a constant force of 150 newtons, and he moves the sled 10 meters. So my force is 150 newtons, and my distance is equal to 10 meters. Work equals force times distance, 150 times 10. Super simple, super straightforward. This is a one-step equation. You can do this all day, every day. All right, so we have two scenarios here, and you have to decide, is it work or not work? So the first one, a man uses 5 newtons of force to pick up a briefcase and move it 3 meters right. So his force to pick up the briefcase, and he moves it side to side. Is that work? That's not going to be work. They're not parallel. So we put no work. A mom pushes a stroller with 20 newtons right as they walk. It would be 20 newtons force to the right, but as they walk 25 meters to the right. So in this case, they're both going to the right. So this is work, and her work would be 20 times 25. Which would be 500 joules. Like I said, super, 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 super easy. You can do this. All right. I want you to try this next one by yourself for just a minute. And we're going to talk about it. Remember that weights can be force. You just have to make sure that you're following your force formula. It says an elevator lifts up 10 people up 78 meters. The average mass of each occupant is 68. How much work did the elevator do? So the total mass would be 680 kilograms. Okay? And the displacement is going to be 78 meters. So all we need to do is first find that force. Force equals mass times acceleration, which is exactly, so we're going to do 680. That's the mass of all of them, times 10. Then give me 6,800 newtons. Then to find my work, 6800 is my force times my 78. That's all there is. Make sure you do your online lab today. You have more than enough time to finish it. It is due by the end of the period. Have a good day and be nice, please.